Hi everyone, welcome to lecture 7 of CSCI 100. In this lecture, we're going to focus on a new concept. We're going to focus on functions. And in particular, calling functions and defining functions. Today's lecture is the first of 2 lectures on functions. And next lecture, we'll learn more details, but today we're focused on what a function is and why we use them, recognizing some of the common functions we've already been using, and also getting comfortable with defining and calling basic functions. To get us thinking a little bit about this area of functions, I'll start off with a question. What do you do when you get up in the morning? Think about your morning routine, how you would describe it to me. If we were in class together, I'd ask you all to tell me, maybe volunteers to raise your hands. Fortunately, I'm the only volunteer here, so I will go ahead and just share my morning routine. Let's see. So the first thing I'll do when I wake up, I would say probably, honestly, if I'm being honest here, I probably check my phone. Of course, that's because my alarm goes off on my phone, but then I'll probably spend time on my phone, which I don't like doing. Then once I actually get up, I'll go brush my teeth. Probably take a shower. I like morning showers. I know some people like evening showers. Then maybe get dressed. I should do this. I don't always do this, but I should make my bed. And then finally, I'll have breakfast. Okay, check my phone, brush my teeth, shower, get dressed, make my bed, eat breakfast. Yeah, that's a pretty good summary of what my morning routine is like. Yours might be different. You might describe it differently. You might have different steps. Some people like to eat breakfast before they brush their teeth, which I can't understand, but some people do that. But notice something interesting about this. Notice how we describe our morning routine, at what level. Instead of saying, when we talk about what we do in the morning, we describe it in pretty high level terms. We say, brush your teeth. Instead of pick up your toothbrush, put toothpaste on it, put it in your mouth, move it around for 120 seconds, which are all the things you actually have to do to brush your teeth. This is called encapsulation. And encapsulation is how we as humans deal with complexity. We break down something complex into smaller pieces that we can reference, that we understand. And you'll notice even in my description here, in my complex description of brushing your teeth, there's even more complexity, encapsulation going on. So picking up your toothbrush, what does that actually mean? Well, okay, you have to reach out, move your muscles. Okay, what are you grabbing? Grab the red stick, if you have a red toothbrush that has hair on it, and then putting toothpaste on it is actually its own kind of set of steps, which is probably you have to pick up the toothpaste and open it, and then squeeze the tube, and then have the toothpaste come out onto the bristles. And so the reason that our parents can say, go brush your teeth, and we know what that means, all of us, is because at some point in the past, we all learned that brush your teeth actually means doing all of these other steps. And as we're growing up, from babies to kind of teenagers to young adults to college students now, you're slowly building up routines and kind of building up layers of encapsulation. So you know what it means to walk from point A to point B. A baby doesn't know that yet. And slowly they build up, okay, this is how I move my foot. Okay, when my parent is calling me over, they want me to walk over, and I know what steps I'll have to take to do that. Now that we have this idea of encapsulation in our minds, let's talk about functions. So what is a function? A function is a way of encapsulating some amount of code to be able to call it from elsewhere in our program. So just like all of those steps in brushing your teeth make up kind of the idea of this is how I brush my teeth, we can do that with any kind of commands or lines or statements, expressions that we would write. We could wrap those and put them in a function, give that function a name, and then use that function elsewhere, which is called calling it. This gives us two important properties. One, we're writing repeatable code. So you write your function once, and then you can use it anywhere. We'll see that in a minute. But two, you also write more readable code, because instead of actually writing the lines of code of what you want to do, you create a function with a name, and then you call that function. And so you kind of are effectively like labeling this set of lines as whatever the function name is that you're creating. Let's see this in code, and then hopefully these advantages of functions will become clear. So I'm going to start talking about actually how we use functions, calling functions. You've been using them all along. You probably just didn't know it. Or maybe you knew it because as hard as I've been trying not to use the word function, I know it's slipped in a bunch of times. At first I tried calling them commands, but it's really hard not to use the word function, and so I'm glad that we're covering them today. All of these below are functions. We had, the first one we learned was print. We would print function, and you give it a string, and it prints out that string to the screen. But the input function was the next one we learned, where you give it a string, it prints it out to the screen, and it takes input from a user and lets you then store that into a variable. Or the way we cast, the way we convert it from one data type to another are also functions, like the int function, which takes a string and converts it to an integer. And if we look at these all kind of next to each other, something should stand out. They're all quite similar in their general syntax. And so the syntax for calling a function, for using one of these functions, is you have the function name. I'll grab my laser pointer here. We have our function name. Here it's just func_name. And by the way, notice the way I'm naming my function here with underscores, a camel case. Then we have the arguments inside of parentheses. So function name, open parenthesis, close parenthesis, and inside of these parentheses we have some number of arguments, which are all comma separated. And this function call is actually just an expression. When Python actually runs, when this code gets run by the computer, it's seen as just an expression, just like a plus b was an expression, or Boolean expressions like is raining and is cloudy. And so when the line of code with the function gets reached, that line of code has to get evaluated. What does it evaluate to, you might ask? Well, the lines of code in the function, whatever steps that function takes, will get executed. And then if that function returns anything, that return value is what the function call evaluates to. Let's see this kind of in action here. This input function, we say, is a function that returns a string, because when this input function gets evaluated, because it's actually an expression, it's a type of an expression, it evaluates to a string. And what is it actually doing? Well, it's taking input from the user, but then that input gets returned. So the input function returns the input that the user typed in, and that returned string is then assigned to the variable name. What about a line like this? We could have num equals int string 8. We say that int is a function that returns an integer because this int function call evaluates to an integer. So this int function takes in the string 8, takes some steps, does something with that string, and then it returns an integer. So this evaluates to be an integer that we can then assign to the variable number. What about print? What does print evaluate to? What does it return? This is also an expression that has to get evaluated. And so print takes in a string, hello world, but it doesn't return anything, right? What it does with that string is then it'll flip pixels on your terminal screen to like draw out the letters hello and world, but it doesn't return anything. So it doesn't evaluate to anything. Functions don't have to return something. They can just do something. It's optional for a function to return something back to the code. So that's why we never see an assignment. We would never see like x equals print hello world, because print hello world doesn't evaluate to anything, and so there would be no value to assign to the variable x. And one more example we've seen, round. Round's a good example of a function that takes multiple arguments. When we have multiple arguments, we separate by commas. And you might be wondering, well, how do I know how many arguments a function takes? And that's specified in the function definition.